In this video, we are going to learn how to solve quadratic inequalities. What are the quadratic inequalities? The quadratic inequalities are inequalities of these four types. You can see you have an expression which is a quadratic equation. Quadratic expression means a expression of degree 2. And then you have four different type of inequalities. So it can be less than, it can be less than or equal, and it can be greater than, it can be greater than equal, greater than or equal. So those are the four different type of inequalities. So if you have this type of inequality, there are four ways to solve such an inequality. So what are those four methods? So the first one is what we call the graphical method. That means we draw a graph. So what we do, we draw a graph. Draw a graph. And the second one, what is called the algebraic method. You're going to use some algebra there, and then you can make an argument. So now I have seen that some students like make a big mistake when you try to solve using algebraic method. They only consider one case, but there are actually two cases to consider. So we can talk about that later. So consider cases. So in this case you do cases. So there are two cases. And then the third one is actually that's my favorite, what we call the sign diagram method. So we draw a sign diagram. We draw a line, and then we put zeros, and then we make a sign diagram. We check the sign of the function. So this is the sign of the function part, and then we check whether it's positive or negative, things like that. Yeah, and that's what we call sign diagram method. And then the fourth method is what we call the shortcut method. And you can remember that, like for example, if you have competitions or like for an advanced class, for example calculus, and then also pre-calculus, you can use a shortcut method. But if you're in algebra or in high school or middle school, make sure that you use the long method, because you need to show that how you do it to your teacher. But if you are in college or in advanced class or in a competition, it doesn't matter how you get it. So you can use a shortcut method. So we can talk about that at the end. So those are the four methods that we can discuss. So let's go one by one. Let's look at the graphical method first. For this problem, we're going to look at a problem like this. X squared minus x minus 2 less than 0. So we can look at the less than inequality for this one. And in another video, we're going to talk about greater than inequality and see how things going to go. So in the graphical method, what we're going to do is we're going to graph the function. So we're going to graph. So graph. Are we going to say the function is y equal x squared minus x minus 2. And you can see that these are degree 2 polynomials, or what we call quadratics. And quadratic have special shapes, like so this is a quadratic. Quadratic have special shapes, and we know that it can be either this way or that way. Now, how do you know which one? And then we know that the leading coefficient decide which way. So in this case, the leading coefficient is 1. So a equal 1. That's the leading coefficient, and you can see 1 is in front. So which is greater than 0. So positive means it is concave up. Positive means concave up. So concave up, or some people call this opens up. Opens up. So going to the positive direction. So that means it has to be like that. So we know that. We notice that it's going up. And then the next one is to find the zeros. So we're going to find the zeros. So to find the zeros, what we normally do is we're going to get the function part, and then we're going to set this equal to 0. And the question is how to solve it, how to find zeros. We're going to use a factoring method. When you use the factoring method, you're going to look at the leading coefficient, and then we're going to multiply these two numbers. This is what we normally call the AC method. We're going to multiply the two numbers. So in this case, you get -2. And then we're going to think of two factors, a factorization of -2 that's going to add up to the middle coefficient. Middle coefficient is -1. That means two factors of -2 that's going to add up to -1 is -2 and 1. And those two other numbers go inside the factorization. So that means x minus 2 and then x plus 1. So next what we do is we're going to set each factor equal to 0 and find the zeros. So that means you're going to get x equal 2 as one 0 and x equal -1 as the other 0. So if you can all the zeros, now we know the zeros, that means we can quickly graph the function like this. So we have the axis, the x-axis and the y-axis, and then what we can do, we can mark those two zeros. So you can see there's a -1, and then also we have 2. So those two are the two zeros, and then we're gonna draw the parabola, the quadratic function, the parabola passing through these 2 points. So we have this one. So we get this. Now what we're gonna do, we're gonna look at the inequality. So what the inequality says is that x squared minus x minus 2 has to be negative. So this is simply the y value. So it says that y value has to be negative, and it's very clear that in this portion you can see in this part from -1 to 2, but if you go down below and you can see here the function, the y value is negative. You can see this part, the y value is negative. So this is where the y value is negative, and this is where the y value is positive. So that's above the x-axis. That's why. So that means this is the region we are looking for. So that means what we need to do is now we're going to find the corresponding x values as a solution. So that means the corresponding x values is going from a -1 all the way to 2. So that is the solution set, because we write the solution set in terms of x. So that's the solution set. So that means you can see that the solution is, you can see the solution is, you can see it's going from starting with -1 all the way up to 2. So that's an open interval, and that's a solution set. So this is what we call the graphical method. And then also you can see that we did not include the corner points -1 and -2 because this is a strict inequality. So there's no equal sign. So that means we remove the corner points. If we had a equal sign, for example, if we had x squared minus x minus 2 less than or equal to 0, then your solution would be -1 close interval to 2 close interval. So that's the answer for if you had the inequality, if you had the equal sign. And then also if you have the other way, inequality the other way, that means then you're going to talk about the outside, because this side and that side, that we can see in a different video. Okay, so let's look at the next method. Let's look at the algebraic method now. So we can look at the same problem. We have x squared minus x minus 2 less than 0. As before, the first step is we're going to factor this. So we know the two factors are x minus 2 and x plus 1. And if you have trouble with how to find factors like that, you can look at the video about quick factorization method, or what we normally call the crisscross argument, and you can find the link in the description. So the next step is there are actually two cases. So what we're trying to do, we try to understand how the product of these two factors going to be negative. That's what we're trying to do. So you can see that this is a product. There are two numbers coming here, two factors. That means there are two cases. The one case is, you can see the first factor can be positive and the second factor can be negative. That's the first one. And then we also have, so, and you can see that when you multiply, you get negative. That's exactly what we need. We need a negative term. And then the other one is, it can be, first one can be negative and the second one can be positive. So this also produces a negative. So there are two cases. So there are two cases. And that's where sometimes the students make mistakes. They do not consider two cases, they only consider one case, and which is wrong, because then you get only half of the solution. So let's look at the first one. So I'm going to consider the first case where I assume that first factor is positive and the second factor is negative. That's my first case. And it is very important to see that there's a word AND. Why we need the AND? Because both should satisfy. The first one has to be positive and the second has to be negative. So that's an AND. And then, oh, this is the other case. What's the other case? first one can be negative and the second one can be positive. So those are the two cases to consider. There are two cases. So we're going to solve them separately. So let's look at the first one. What this says, if you add 2 to both sides, this can be x greater than 2, and the other one says if you subtract 1 from both sides, x is less than negative 1. So that means these two should be satisfied at the same time. So the easy way to see this is, let's draw them on a line and see what you get. So first one we're going to get, so it says that x is bigger than 2. So that means on the right side, larger side. Now let's look at the other one, which says that x is less than negative 1. That means on the left side, less than left side. So you can see that these two should be satisfied, and you can clearly see that there's no number on the number line that satisfies both of those inequalities. So that means in this case there are no solutions. So this implies that no solutions. But you can see this is only one case. There's another case. So that means first case doesn't give anything. So let's look at the second case. As before, so you can see second case, if you add 2, it says that x is less than 2 if you add 2 to both sides. And the other one also says that if you subtract 1 from both sides, x is bigger than negative 1. We subtract 1 from both sides. Now let's graph them again. So this is the first one. What she says that x is smaller than 2. So that means x has to be, the colored one is the solution for the first part. So this is the first one. It says x is smaller than 2. Now let's do the second one. So this says that x is bigger than negative 1. So that means you're going to color the right side. So now you're going to see whether is there anything common. And you can clearly see that if you pick numbers between negative 1 and 2, and you can see if you pick any number in between these two, and you can see any of those numbers satisfies the inequality. So that means the solution is going from negative 1 to 2. So the solution is simply in between. You can see it is in between negative 1, open negative 1 because there's no equal sign, and open 2. So the solution is in between. If you pick any number in between that satisfies both of those inequalities, so that means the solution set is going from negative 1 to 2. So the solution is, if you write as an interval negative 1 to 2. So that is the solution using this method. So that means the only second case work. So let's look at the third method now. Third method is a sign diagram method, and this is my favorite method because this works for many problems and it's not that difficult. It doesn't take much time. So let's look at how the sign diagram method works. So we can look at the same problem. We have x squared minus x minus 2 less than 0. As before, we're going to factor. That's the first method, first step. So it is x minus 2 and x plus 2. Those are the factors. And then what we can do, the second step is we're going to find zeros. So find zeros. That's the second step. And we know the two zeros in this case is x equal 2 and the other 0 is x equal negative 1. So those are two zeros. And then what we can do, the third step is we make the sign diagram. So make a sign diagram. Make a sign diagram. So this is like a very important technique. It's useful for many problems. So we draw a number line, and then we're going to put those zeros in the right order. So this is negative 1, which is open because there are no equal sign. This is 2. And then what we're going to do, after you put those numbers in the right order, we're going to pick test points. So I'm going to use T to mean the test point. So what's the test point I'm going to pick? Any point on this side. And you can see, for example, T equal 3. The test point will be 3. Now what we're going to do, we're going to plug in that value into this factored version because it's very easy to simplify. So if you plug in T equal 3, and you can see that it is T minus 2. So you're going to get T minus 2, which is 1. We only need the sign. So you can see it is positive. So we say plus means positive. Now you could plug in the same value in the other factor. You can see it is 3. So if you plug in 3 in the second factor, you can see you're going to get 3 plus 1, which is 4. That means which is also positive. So positive means positive. Now do the same thing with each interval. So for the second interval, if you can see 0 is one of the value, just go for it, because that's going to make the calculation very, very easy. And you can see 0 is in between, so I put 0 as a test value, t for test value. So again, if you plug in t equals 0, from the first one is -2, so which is negative. From the second factor, you can see if you plug in 0, you get +1, which is positive. So negative positive means negative. And then for the last one, we can see you can plug in t equal -2. That's a good value. I mean, you can plug in -3, -5, -10, anything, but -2 would be a good one. And if you plug in -2 in the last factor, you're going to get -2 minus 2, which is -4. That means which is negative. And if you plug in -2 in the second one, you can see -2 plus 1, which is -1, so which is also negative. So negative means positive. So that's the sign diagram. So we call this is the sign diagram. Sign of the function. We say sign of f. Sign diagram. Now what we can do? Now we can look at the inequality and test, pick which one you want. And you can see according to the inequality, you see that the expression has to be negative. So that means this is the part where you see negative sign. So that means the solution set is only from going from -1 to 2. So that's the solution. So that means we can pick the solution now. So according to this one, so we're going to pick the solution now. So that's a step 4. So pick the solution or select the solution. Pick the solution. So you can see it is simply going from -1 to 2, and you can see it's open, both open, because there's no equal sign. So that's the solution using the sign diagram method. This is a very powerful technique. So let's talk about the last one, the shortcut method. So shortcut method, what we can do is actually according to the sign diagram argument. So what we do, as before, it is x squared minus x minus 2 negative. We look at the factors. So the factors are x minus 2, x plus 1. And then what we can do, we're going to find the zeros as before. So the 0 is x equal 2, and the other 0 is x equal -1. So the argument is, if you see less than inequality, it is inside. That's how we say it is inside. So inside. If it is greater than inequality, it is outside. So it's so simple. So that means in this case, this is a less than inequality, we're gonna find the solution as inside those two values. So that means if you look at the number line, and what gonna do is, so we have -1 here, we have 2 there. So it is open because it's strict inequality. So what it says, inside means between the two. That's what inside means. So if it is less than, it is inside. Greater than, it is outside. So if you have a greater than sign, we can pick the outside. So it's inside, outside. It's very simple. So that means your solution is so you can see -1 to 2. So that's the solution. So simple. That's the shortcut method, and you can use this for advanced classes like calculus, pre-calculus, things like that. Okay, now you can try these practice problems using any method you like. So in the comment section, write your favorite method and why you like it. So thank you so much. Now try to solve these problems using any of your favorite method discussed in this video. So my favorite is the sign diagram argument because that's very useful and you can apply for many problems like this. Thank you.